Okay, so hi guys. Give me a second really quick. 1 second. Okay, so in this video what I want to do is go over these problems here. They're pretty so this topic kind of goes over functions, right? And I want to start with these problems. This is kind of I only made up 4 problems for this video because it's kind of like part 1, I would say, about classifying functions and stuff, like from a table, from a graph, from, a relation, and from an equation. Um, so this is kind of part 1 of that. So, we're just gonna dive right in. So, it says determine whether the table represents a function. And this is for, by the way, this is for college algebra, if you're in college algebra. So now, we're starting to look at functions. We are done with looking at, inequalities and stuff like that. So the first problem that we have is a table. Now, there's a few things I want to say about a function, just in terms of definition. So a function is usually defined by so we know that f of x, this is f of x, right? And you put in a value for x, you get something for y, right? Now, in terms of a table, I do want to say that it's only a function when there are no repeated x values. So no repeated x values. If there are no repeated x values here, then it would be a function. So for example, this one we have 1, 0, 2, -5, and 3, 3. So there are no x values that are repeated, right? So obviously knowing that that main point, then we know that this is a function. Okay, so I really want to kind of make that very clear, that when there are no repeated x values on a table, there can be repeated y values, but no repeated x values. If there are repeated x values, then it would not be a function. So if there are repeated x values, it would not be a function. And if there are no repeated x values, then it would be a function. So this one is a function, obviously. Okay. Number 2, or part B, gives us this, this relation. We call this a relation. So basically, this would be in set builder notation. At least I think it would be, or it's a set of, of coordinates. So looking again at only the x values, we have a -2, a -1, a 0, a 1, and a 2. You only want to look at your x values, okay? So only look for repeated x values, okay? So obviously, looking at this, there are really no repeated x values. So this is a function. Okay, so it's okay for it to have repeated y values, for a function, right? For it to be a function, but no repeated x values, okay? So then for part C, we know this is y equals x squared plus 2x minus 1. And obviously, this, if, there are really not going to be any repeated x values, because as long as y equals f of x, and as long as y is equal to, as long as there are no y squared terms or y to the 1/2 or y to the n, where n is not equal to 0, then as long as there's none of this going on, then it is a function. Versus, the next problem that we're going to do, but this is a function. Okay. And then part D talks about, this is yet another equation that we have. So notice that there's a y squared here, okay? And a function can only be defined when there are, like I said, there are no y to the n terms where n does not equal 0. So notice here we have a y squared term. Obviously that does not equal 0, that equals 2. So we have y to the n, and we know that this is y to the second power, right? So n equals 2. And that tells us that obviously this is not a function. Okay? And obviously, we'll get more into this kind of stuff once we start graphing functions, like, once we start graphing like circles and everything like that. You'll understand what I mean when I say it's not a function. So, because this is really a circle, it's a conic section, but conic sections are not really considered functions. They're relations. So a relation is just, it can be anything. It can be so that's another thing. A relation is a kind of like a relationship, between x and y. So basically, like, a relation can be like, if you have 3, 1, 4, 2, 5, 3, 3, 2. You can call this a relation, but is it a function? If there are repeated x values, there's one here and one here, then this is not a function. Okay, so that is kind of what I wanted to go over in this video, guys. Actually, let me make up one more problem. So another thing about functions, let me just kind of show you guys about the vertical line test. So the vertical line test is something that we use when we, to see if it's a function or not. So for example, let's just say I have this kind of this curve. So basically, in this, we use the vertical line test, and what that means is we're going to draw vertical lines all over the function, all over the curve, right? And we want to see if there are any repeated parts where it crosses that curve. So you see how everything is just, it only crosses it once, right? There are no, there's nothing that, it doesn't cross twice. So we know that f of x is definitely a function. So we know that this is a function because it's only once that it crosses, right? It just crosses once. And obviously this is the test that we use for when we determine whether or not it is a function. Now I do want to give another example where, let's just say, I don't know, let's see, so, I don't know, let's just do this. Let's kind of do this right here. So we know that this, if we do the vertical line test, right, it crosses here, 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 it crosses here. We don't want this to happen when we're trying to figure out if it's a function and it crosses twice like that with the vertical line test. Then this tells us that this is not a function. Okay. Now I do want to give one more example. Let's just say I go ahead and say y squared is equal to, I don't know, let me do this. Hold on. So let's say I have x plus y squared equals 4, right? And I say, is this a function? So we're going to try to solve for x, right? I have y squared equals 4 minus x. We're going to try to solve for y, excuse me, not for x. And we're going to take the square root of both sides, and then what we get is y equals plus or minus the square root of 4 minus x. We can't have this going on, okay? No, we cannot have this. We don't want this. So no. So this is not a function. Okay. Let's see. I believe that's mostly it for these. Yeah, I believe I went over mostly everything. And again, also if they give you a table and they say, well, let's just kind of say here, give you a little table, and they're like -2, 1, like -1, 0, and 0, 5, and 0, 6, and 1, 1, and 2, 4. And they ask you, is this a function, right? Is this relation a function? Look at your x values. Always look at your x values. Are there any repeated x values in here? Well, there's this one, and there's this one. So obviously 0 is a repeated x value, meaning that the definition of a function is every input has exactly one output. So every input has one output, has only one output, okay? So, so basically we need to, that's the main idea of this. And because this input has has two outputs, then no, this is not a function. But it is okay if I say 0, 1, 2, 1, 3, 5, 4, 6. It's okay for this to happen. In functions, okay? Only in functions, only in original functions. I don't want to confuse anybody, so I'm not going to get into inverse yet, but this is okay for functions. So, you know, if you kind of plot it a little bit here, this is 0, 1, and let's say we have 1, 2, so we have 2, 1, and then we have 3, and let's just say it goes, let's say here's 5, so 3, 5 right here, right? It's 3, 5, and then 4, 6. So 4, 6 is like, I'll just put 6 right here. So 4, 6 would be like right here about. And it's okay for it to have, this is okay. So, I mean, it's okay for it to be this way because it still follows the vertical line test. Every input has only one output, okay? So that's kind of the basic definition of a function, guys. Also, like I said at the very beginning, f of x, they call it f of x. So this f parentheses x, they call it f of x. And g of x and h of x, right? That's just how they call it. And that's kind of the main thing that we have to know about these kind of problems, okay? So this was kind of a brief intro about functions and function notation. I will go more over like the graphing part, you know, in another video. But you just have to know that for any graph, or actually, if you know, for the graphing part, the only thing you have to know is that for a function, all you have to know is basically that you know, it has to follow the vertical line test. I might go over one-to-one functions and inverse functions in another video because those are a little bit more, it's a whole different thing, and I don't want to go over it in the same video because I don't want to confuse anybody. Right now we are just looking at functions and we're just looking at the basics of functions, but in another video I will go over one-to-one and inverse functions. So this was kind of, I guess, part 1 of functions. So if anybody does have any questions, please do let me know. And also, please like, comment, and or subscribe. And thank you so much for watching, guys. And I will see you guys in the next video. Bye, guys.